Good morning, everyone. Good afternoon for people outside Pacific's time zone. My name is Robert Schmid, Deloitte Digital's Chief IoT Technologist, and also known as Mr. IoT. This week on Coffee with Mr. IoT, my co-host Rachel Mohrmann and I are talking with Sid Verma. Sid, how are you?
I'm doing good, Robert and Rachel. How are you guys?
Good. Mahesh Chandramouli. Mahesh, how are you? Just say hi.
Hey, I'm doing good. Hi,
And York
Robert.
Prado, the one with the white background. York, how are you?
I'm good. How are you?
Great, thank you. Thanks for joining us. And the topic of today is build right and build to scale. And what we meant by that is it's an interesting time today. When I look at IoT, there's a lot of different experimentations and pilots going on. What I've also noticed is many of the pilots are built, it's so easy to build today. People buy Raspberry Pis, they put a bunch of PHP pages together, and off we go, and we have IoT. And then what happens is it doesn't really scale. So who we have on the call with us today, Sid, Mahesh, and York, you guys are the authors and developers of what we call the Deloitte Reference Architecture. Mahesh, tell us a little bit about that. What is it, and why did you develop it? What's the intent behind it? Just tell us about it, and tell us why that's the start for us to create something that scales.
I think the idea about the reference architecture altogether is we built a framework which is the information value loop, and then we wanted to extend the framework and then make it much more at a generic level that any IoT solutions which we are building, this would be more like a reference architecture. It will start from create, communicate, aggregate, and analyze. And what we have in create, what will happen in communicate, what will happen in aggregate, and what will happen in analyze. So we have a holistic view about how we can architect solutions in the IoT space. So that's where the whole vision started. And we also have things where we can apply different platforms in our architecture and then see where it can fit in and which zone basically it's going to be part of it. For example, if it is edge computing, where it's going to fit in, if it is something to do with data aggregation, where it's going to fit in and all the stuff, and it has the flow and the transmission process, and it's got the end-to-end capability.
And why is it important to see all those pieces when you start? So you mentioned all the way from the sensors to the aggregation to the act. Why look at that? I mean, this is, for a lot of companies, this is something new. It's a lot to tackle. It's a lot to absorb all at once. Why is it important to look at everything holistically from the beginning?
It's one is right. So you right now most of the applications you see is basically tightly connected. So you can't disconnect it. So the way we are thinking is by segregating into different layers. What it's going to have is from the things to the sensors, we're going to have the data stream, which is basically the downstream data, right? So, and then how it's moving and transmitting to via gateway, and then how it goes from the gateway to the aggregate. Because if you don't have this process flow, what's going to happen is you're going to have ad hoc requests everywhere, and there is no standardization, and you cannot know whether this data is coming from this sensor or is it coming from a mobile device. So you have no visibility to that. So if you go it in this fashion, it's more procedural, and you got stage gate process in each, and you can also troubleshoot what's happening on each stage, and also can stream the data in all the way into the cloud.
Mahesh, question for you. What's different about an IoT reference architecture versus what companies have today?
So the reference architecture, so the companies have today is more about or relate to a particular solution or a particular use case. What we are trying to do is we are taking one level up and looking at things at a more hierarchical, and also looking at things in a much more 360 view of how this architecture can help from in terms of IT infrastructure to business, how they need to prepare themselves. Say, for example, we're going to have these sensors, how IT needs to basically prepare themselves. That's one area. So this is more about the holistic view the architecture is going to help shape companies' things in the right direction, and also understand what are the components inside each to call it as a true IoT platform and
So
true IoT solution.
One of the things that happens too is, if I understand this right, I always say there's big data and then there is IoT, which is huge data. The data volumes are very different in IoT. Rachel, you're shaking your head.
no, there's so many new terms for it. The big data, the massive data, the IoT data. In fact, we were just looking at our own proof of concepts and running into some issues there ourselves and working through it. So I think even with expecting it, it's still so much bigger than most expect. So you're absolutely right.
So Mahesh, what's in the reference architecture that accommodates huge data?
So there are a couple of things, right? So the way I would think about is one is in our aggregate and analyze, right? So we have a data ingestion point. That's where the data comes in, and then once the data comes in, there's two types of data. You have a cold and a hot, right? So where you can also build some real-time analytics, which is currently missing in most of the solutions. So the key is around the real-time analytics feature. That's one. Two is we also look at data in terms of structured versus unstructured, because of some sensors and some data which can be unstructured too. We look at that, and then the data at rest, which is mostly used for large volumes of data over time, right? So we can get insights from that data. That's where our analyze layer does. So do you want to go anything deeper on that, Robert? So I can go deeper.
No, this is great. I mean, you talk about real-time analytics and you talk about unstructured data analysis. That's all great. Maybe my ask for you, Mahesh, is while I'm going to switch over to Sid, if you have the reference architecture and you can do a screen share for us, then I think that'd be great.
Oh,
but
okay.
other than that, Rachel, what question do you have for Sid? Let's get Sid going.
Yeah, no, I was going to pass on the data lines. I think, Sid, you've been working with some of our clients, and the notion of taking all this data and doing something with it, is that always applicable? Should we always be thinking of all the data points, or how do you help clients think through what data is really important and what to actually do with it? Because I think, we saw the trend going from sensing and getting all this data actually to acting on it. So how do we help our clients think through what's important to act on and making those decisions?
That's a very valid point, Rachel. Actually, going backwards from sensor to collecting data is a backward way of looking at a problem. Means how we look at the problem is the other way around, which is why do you need a data and what's the business problem you're solving? So let's assume you want to do a predictive maintenance on an equipment that is very near and dear to you. So the first step is, what are the parameters that you want to look at in terms of failure? So let's say motor failure is something that, or grinder or binding failure is something important to you. Then you ask your data scientist to say, hey, which are the variables, if I actually give you, at what frequency will actually help you create a predictive maintenance equation for you? And then we go down the food chain, find the motor, where should we put the sensor, and then put it all the way up. So if you do that, the data volumes actually are not that staggering anymore, although there are a lot of time series events that happen, but time series events are easily to handle as compared to collecting everything available to you.
You make a great point. So thinking about the end goal or the end problem or what you're trying to solve, and then working your way back. So if we were to look, and I think, Mahesh, we have the reference architecture up, and we could use that as a visual.
Yeah, so I do have it up. So can you guys see it?
Yeah, so thinking more, Sid, to your point, on the act arrow going back or on the analyze piece, and then working your way backwards to see what's required across that sensor and data transmission.
Correct. So in the traditional model, when you do BI, most of the stuff that you get is from an electronic transaction, and that is a platform, and then you do analyze. In the IoT world, we stretch the horizons on the left and actually on the right. So what you're able to get is not only you get a transaction data from your SAP or CRM, you started getting data directly from the things. And you can actually dictate how often do you need it. And the act part of it is the most beautiful part. You can make things happen now. Like in the BI world, you press a report, or you give a presentation to the CEO. Here I can actually stop a machine from working if it is too hot, or I know that it's going to make my output like rejected from a QA point. Example would be there is a milling machine. You did at too much vibration, the output is going to get damaged anyway. So let's stop it. So it'll protect your output, it'll save your time, and it'll also protect the machine. So that's an example of the act and going backwards in the value chain in IoT.
Thanks, Sid. That's really good. Sid, so first of all, if you're just joining us now, I'm Robert Schmid, Deloitte Digital's Chief IoT Technologist, and you're watching Coffee with Mr. IoT. Today we have Rachel Mohrmann and I with Sid, Verma, Mahesh, Chandramouli, and York Prado, and we're talking about building once and building right for scale. Sid, there is one box on there that always fascinates me. I find it's one of those boxes that only happened very recently, and that's really enabled by chip prices coming down, chips being so much more powerful. Talk to me about edge processing. What's new about this, and why is that so important to IoT?
So that is actually the new thing that has created a revolution in IoT world. So most of the work that we see before, the big data actually plays in the large databases on the world. But now that you have started to connect to real world things like a Coca-Cola vending machine or like a milling machine, you don't want to take the data all the way up to make a business decision. Because a lot of these decisions are actually not business decisions. Some are very tactical decisions which can be handled at the edge. Earlier, it was difficult to do. As you said, it was expensive. The compute power was not there. Communication protocols were not that easy. Nowadays, if you go to any mall, you will see a vending machine and there is a small antenna coming out of it. That is like somebody has put in edge computing on it to just say, am I running out of Coca-Cola cans now? Like earlier, people used to just run around, check every hour or every day or every week to see, and sometimes you run out of stuff. So now edge computing is the power that is on the top of the smart device that allows you to have an OS. You can actually program it with the logic you want. You can almost take all the data come from sensor and even take data from other sources like weather if it is important and make a lot of credible decisions in that area. And sometimes it is very, very important to do that because the latency is something that is important to you. So if you have a fire suppression thing on your machine, you don't want to wait the data to go all the way to the cloud. Sometimes your packets get stuck, it takes too long, and you want to just shut it down just to prevent it from burning up the whole factory, let's say. And you can do it on edge right away. So that's the power of edge, Robert.
I love your example of the Coca-Cola machine. I talk to people too, and they're like, edge computing, that sounds like sci-fi, futuristic. And I think a lot of us, though, have Nests or sensor-enabled thermostats in our home, and really, most of them are doing edge computing to figure out your trends and then reacting and taking those to the next level. So I think that you bring up a great point that it's real to now and it's something accessible across different industries. And really something that people should be considering as, again, going back to your point, what's the goal, what's the outcome, and then working back to find the right solution.
Yeah, just to add on to it, it's all about pre-processing, right? It's all about pre-processing the data at the sensor, and as per Gartner, there's also 40% of things are going to move into the edge processing. That's where the IoT is going to basically bring in, which is the point which Robert brought in the LiveWorks conference at the keynote last week too. So I think it's a very critical, it plays a very critical role in the whole ecosystem.
So I have to say it's funny that you guys use the vending machine. I don't know if you know this, but the very first example that's documented about IoT actually happened at Carnegie Mellon University, and it was the students who didn't want to go from the 8th floor to the 3rd floor where the vending machine was. And they connected that vending machine to the internet, and so that was in the late 80s, and they called that, I mean, it wasn't called the Internet of Things back there, but that's supposedly the first example of this document.
Wait, I still don't get it, though. How did the food get from the other floor down?
Oh, no, it didn't get to the floor. That's robots. But what it did is, if there was, I'm gonna use a different example, not to pitch the same company again. Maybe it was Red Bull, but because I'm Austrian, I have to do that. But you know, if the Red Bull was empty, then I wouldn't go from the 8th floor to the 3rd floor. So that was what happened. It just gave you a status if it was there or not. It didn't bring it to you. It didn't it didn't like give it to you. It just told you if it was empty. So I find that quite
time. I got it. I got it.
So you've been really awesome and quiet, and you've been a big part of the reference architecture. You know, we talk about this sort of, I don't know, sometimes I find people find that dry technology. I personally, you know, edge computing to me is something so fascinating. I could talk about it for a long time. What about the reference architecture fascinated you? What's the stuff that excites you about technology when you look at IoT? Just tell us a little bit about that.
So I guess I'm more on the technical side. I'm more on the development, and I guess what kind of excites me is exploring these new platforms that are coming out, or taking older platforms and then combining them to something that can actually ingest millions of messages an hour, billions of messages a day, being able to kind of analyze that, combine that with other types of data, and then ultimately driving those business decisions. There's a lot of articles out that tell you it's like ultimately what it boils down to is these things that you're sensing. You kind of want to look into the total cost of ownership, right? You want to know great use cases out there, that great amount of training out there that we've been through, and so there are just great examples out there that other companies are doing and we're doing as well. Another company was looking at kind of a robot machinery. Just they didn't have any insight of why things were breaking down or when they were expected to break down. They just they would just break down. They get a notification, they turn it off and on again, and then that's it. Like there's no maintenance schedule for those. They don't really know why it broke down. But now, because of IoT, because of adding all these sensors, they have that information where they can actually, have insights, when they can actually get a kind of scheduled maintenance lockdown, a predictive maintenance, things of that nature. And so that's kind of what excites me: the platform, the implementation, as well as the analytics. And there's just those are just growing fields.
Where's your closest sensor to you? I have mine on my wrist. Where's yours?
I currently have none.
Oh my God! Did you not get the backpack yet? I sent you 2 days ago.
I just got the backpack and the tile, so thanks for that.
I didn't get a backpack. What the heck? I want a backpack.
It's actually a pretty nice backpack. But yeah, so appreciate the letter and the tile. I'm actually gonna connect that tile to my keys because sometimes I lose them. So
for those who don't know, what's the tile, York?
Basically, just a Bluetooth low energy kind of device that you can connect to anything, and you have an app on your phone. You can do things like locate and like make it beep. So in case something kind of if you need something or want to watch over something, you can attach this tile. And Rob is actually holding it up right now.
And you could attach it to your kid, right, and know where they're at all times.
Yeah.
Rachel, you don't have kids, do you?
I was thinking Sid, based on the fact that he has to go to the father-daughter thing going on soon. But while we have this this great brain trust here, and I know all three of you gentlemen are really involved in helping our clients think through this, and as we have the architecture diagram up, I just want to ask more broadly to everyone, where do you see our clients make a gap or a mistake or have to go redesign their initial architecture when they first set it up? So which part of this do we see the gaps, and how can they avoid that? Because I think a lot of people going into this are relatively new and they don't want to make the mistake. So I'd like to get your thoughts and your insights based on what you guys have seen. Don't all jump in at once.
I can take the lead. So I actually came from the engineering world, and the big challenge that you see in IoT is the OT and the IT paradigm. So means in traditional engineering companies, the IT do not have a lot of stake in the ground in terms of running stuff, and the OT engineering people are not the smartest, like not like no derogatory word, but they're not the IT smart. They are function smart. So what happens when you try to implement IoT is one of those parties starts and takes the lead, and the implications of the broader IT never get solved because one part actually starts doing the pilot, and then the pilots get shelved because they cannot go into a broader IT. So to start with the broader challenges, like security is something that IT handles a lot better than OT, like generally, because OT just firewalls everything and doesn't allow people to go out. That's a different way. The data that comes in is different data, like transactional data doesn't show up the way IoT data shows up. So the IT guys have the challenge around handling something which is an OT data, which is real-time time series data, is like their transaction. So they have to build databases and WebSockets and like communication protocols to handle these. So these are like one of the early challenges that I have seen. And then the last big deal that I have seen is people experiment in IoT by randomly collecting stuff over machines or factory or like houses. They forget the data modeling part of it, which is why do you want to do it? Let's make a data model and then collect data. Let's not do backwards. It's like, hey, I have sensor, let's collect it. It's like I have a solution I don't have a problem for, and then the pilot runs out with no business value. So these are the big three things I have seen.
Sid, before I hand it over to Mahesh to have his closing thoughts on where the gaps are, I ask you the same question. What's your closest sensor that actually does something meaningful for you rather than just as a sensor?
Called iPhone 6. It has so many
Come on,
sensors.
you gotta have something better than that.
But it has everything I need. Like it has Fitbit, it has accelerometer, it has a camera, it has everything. I don't need more than this, except for what you gave me for Christmas last year. I still have that blinking which gives me temperature in my room, which doesn't match my iPhone temperature. So I don't know which one is correct.
Oh, it has to be the other one I gave you, but I trust it's good. Thank you, Sid. Thank you so much. So Mahesh, now back to you. Rachel's question. Where do you see the biggest gap? Where do you see people make the biggest mistakes and forget about it?
Yeah, the biggest mistake I feel like adding on to Sid is like they think that the device managers, you're going to have this hundreds and thousands of sensors. They think it's going to be the device management piece. The focus on that is very, 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 very critical in terms of the whole ecosystem. So I think what people think is they say we'll do an M2M kind of a design to manage it, but it's not the same way because this it's completely different. So focusing, so that's why if you see in the aggregate layer, there's a big piece where we defined it with this device management, which is mostly the centerpiece. So I think the gaps are really big in that space, and the platforms and other vendor platforms already provide these kinds of capabilities out of the box. So, but to design and architect the device management is a little bit of a challenging process. But once you get that right, I think it's running a business is going to be very smooth. You know exactly what's going to happen when the device needs to be provisioned, what's the battery status on the device, all the stuff.
It's interesting, Mahesh. I remember when I had to run IT and we talked about managing mobile devices. This was hard enough as an IT organization. Now, if I have to imagine running devices that sit outside my firewall, or I have to update firmware, that's a whole new ballgame that many of us haven't been in. And really, I don't know, I want to ask you, is it true? But if I look at this, I'm thinking I'm taking a page out of the book of mobile operating system providers, and they, to this day, are improving their device management. Is that a good approach to look at those and see what they've done?
Yes, yes, definitely, Robert. And also, it's also a good approach to look at some of the device management products too, like where they specifically focus on device management, looking at that and seeing how You can do provisioning. You can do firmware updates, and it depends on the OS too, right? It gets much more complicated when you have multiple OSs, and then you have to manage that. So that's why I would say, like, looking at those products would help us a lot. And I think that we can bring in we have a lot of expertise in that area. We can bring in a lot of value in that space too. And we are also working with clients to shape how to manage these devices, which is because the devices are this whole ecosystem is in the disruptive technology world, right? So what do you see now, and 3 months time, it's completely going to be different. So how do you adapt to it, and how do you manage those devices is a big problem.
Hey Mahesh, thank you so much. It was actually funny. We didn't get to see your face whenever you talked. We saw the reference architecture, so thank you for sharing
that.
No,
I just kept it because you already saw my face.
Mahesh and reference architecture are the same thing, so.
Rachel, before we close it, any closing thoughts before I close it down?
No, I think my key takeaway from what Sid and Mahesh and York shared was really thinking through the business problem, thinking through it holistically with business and IT not working in separate silos, and then really setting up the right framework to be successful long term pays dividends. If you just start early, start fresh, set the right building blocks, then you'll be enabled for success, as opposed to, where you were mentioning, Robert, all those pilots that start and never make it. So I took down some notes, and hopefully this is helpful for others as well. So thank you guys very much for that.
It looked like this coffee break is coming to a close.
I'm waiting for it, Robert. I'm waiting for it.
I repeatedly say, think big, start small, scale fast. Today we talked about ways to enable scaling fast to the right platform. And I have to tell you, what Rachel is referring to is we typically show our shoes. I'm not wearing any shoes today, so...
Do it! I dare you.
You want to see my socks, huh? Okay, let me pull up my socks. I have cool socks. So, Rachel, what are your shoes?
Nothing fancy, but at least I have work shoes for once. So I really can go to an office and wear professional shoes once.
For anybody who doesn't know what we're doing and thinks this is super geeky, it is super geeky. But we had a discussion many weeks ago with Tracy about retail, and they gave me a hard time because I kept using hardware retail examples when they wanted to talk about shoes at high-end stores. So ever since then, we show our shoes. Mahesh, if you feel like showing your shoes, please go for it. In the meantime, thank you guys for joining. And please join Rachel and me again next Friday, 9 a.m. Pacific, noon Eastern, for another Coffee with Mr. IoT. And by the way, if you missed anything, you can see this on YouTube. Thank you guys. Have a good one. Bye.
Thank you.
Bye.